Hello everyone, this is Kalpana here. In this video, we're going to see a problem using method of undetermined coefficients. So let's get going. Problem: solve d square minus 2d plus 3 into y equal to x cube plus sin x using the method of undetermined coefficients. We are given a differential equation d square minus 2d plus 3 into y equal to x cube plus sin x, right, which is in operator form. Say f of d into y equal to some function of x where f of d equal to d square minus 2d plus 3 and q of x equal to x cube plus sin x, right? And also we can write the given differential equation as d square y minus 2 dy plus 3y equal to x cube plus sin x, right? And we can write d square y as d square y by dx square minus 2 into dy by dx plus 3y equal to x cube plus sin x, and d square y by dx square can be written as y double dash minus 2 into this can be written as y dash plus 3y equal to x cube plus sin x, right? So we are asked to find d square, solve this equation or this equation, both are same, right? You can ask any of these three, in these three types. Okay, the same problem can be asked in any of these three ways. Fine. Now coming to the problem, the general solution to this equation is given by y equal to yc plus yp. We can find yc using auxiliary equation. Later we'll find yp using trial yp with the help of yc and q of x. We'll see that later. Now coming to yc, we'll just begin with the auxiliary equation to find yc, and later we'll go for yp. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 3, right? Let's replace the differential operator d by m in f of d, so that we'll get f of m equal to m square minus 2m plus 3, and the auxiliary equation becomes m square minus 2m plus 3 equal to 0. Now we need to find roots to this equation, right? Now we'll find roots to this equation using quadratic formula. M equal to minus b plus or minus square root of b square minus 4ac by 2a. Just compare it with am square plus bm plus c to find the values of a, b and c, where a equal to coefficient of m square 1 and b equal to coefficient of m minus 2 and constant c equal to 3. Now substitute these values in this formula. You'll get minus of minus 2 plus or minus square root of minus 2 whole square minus 4 into a into 3 by 2 into a1, which gives us minus into minus 2 2 plus or minus square root of minus 2 whole square is 4 minus 4 3 is 12 by 2, which gives us 2 plus or minus square root of 4 minus 12 is minus 8 by 2. Okay, we can write square root of minus 8 as square root of minus 1 into 8, 4 into 2 by 2. Now split the square root, you'll get square root of minus 1 into square root of 4 into square root of 2 by 2, which gives us 2 plus or minus, and square root of minus 1 is I. We'll get I into square root of 4 is 2 into root 2 by 2. Now take 2 common from the numerator. If you take 2 common from the numerator, you'll get 2 times 1 plus or minus root 2 by 2, where 2 gets cancelled, and finally you'll get m equal to 1 plus or minus I root 2. You have I also, right? So you'll get I into root 2. Therefore m equal to 1 plus or minus I root 2, a pair of complex conjugate. We know that when m equal to a plus or minus ib, yc looks like e power ax into c1 cos bx plus c2 sin bx, right? Now compare roots with a plus or minus ib, then we'll get the complementary function to our problem. Y is equal to e power, for a equal to 1, you'll get 1 into x into one constant, say c1 into cos b, that is root 2 into x plus c2 sin b, root 2 into x, right? You can write this as e power x into c1 cos x root 2 plus c2 sin x root 2. Therefore, y is equal to e power x into c1 cos x root 2 plus c2 sin x root 2, right? And we have q of x equal to x cube plus sin x. Now, compare the functions of q of x and functions of yc. Here you are having x cube, you don't have any x cube in this yc, and you have sin x, you don't have any sin x. So by comparing q of x and yc, we can say that therefore q of x has no term common with yc, right? So therefore yp must contain the linear combination of q of x and all its linearly independent derivatives. Okay, since the terms of q of x and yc has no, q of x and yc has no common terms, so we'll find yp, or we'll choose yp using our q of x. Okay, and yp must involve x cube and all its derivatives, likewise sin x and all its derivatives. So let's see. We have q of x equal to x cube plus sin x, right? When q of x is x cube, then the terms of yp should contain, you'll get yp directly a formula. I'm talking about the formula, okay? A naught x cube plus a1 x square plus a2 x plus a3, that's it, plus a3. Okay, likewise when you have sin x or say some sin ax, let it be sin ax or cos ax. When you have sin ax or cos ax, and yp corresponding to this q of x will be a naught sin ax plus a1 cos ax, or we can write it as a naught cos ax plus a1 sin ax. Okay, we'll see how. Now, without remembering the formula or just blindly remembering the formula, we'll see how to find or how to choose yp using q of x. Okay, we'll see that. See, q of x has a term x cube. Okay, now yp should contain a term which is in q of x, right? Yp should contain this. And find the derivative of x cube, you'll get 3x square. Find its derivative, you'll get 2 3 is 6x, and its derivative is 6, right? You have terms x cube, x square, x and a constant, just neglecting the constant equations 3 and 6, just by neglecting the constant equations I'm saying. Okay, if you take x cube, find all its derivatives, right? Now, okay, let it be. Coming to another term, sin x. You have a term sin x in q of x, right? So yp should contain this sin x and its derivative. Derivative of sin x will be cos x. Again, find its derivative. Derivative of cos x is minus sin x. Again, minus sin x derivative is minus cos x. It just repeated. I mean, you'll get sin x or cos x. Either sin x or cos x. Sin x, cos x, sin x, cos x. Just continues like that. Or see, minus of derivative of cos x is minus sin x, right? Okay, and find its derivative. Derivative of sin x, minus into minus plus. Derivative of sin x is cos x. You'll get sin x, cos x, sin x, cos x, sin x, cos x, and only you'll get sin x and cos x by differentiating sin x. I mean terms of, not terms, from q of x, sin x, you'll get sin x and cos x simply. Okay, now let's write all the functions of x and this constant in one set. That is, we are writing q of x and all its derivatives in a finite set form. So here we'll get x cube, x square, x, a constant, and sin x, cos x. You'll just take one sin x and one cos x. Okay, you should not repeat the terms in this set now. Okay, fine. Now I wrote q of x and its derivatives in set format. Okay, now using this set format, I'll write yp. Yp equal to one constant into x cube, another constant into x square, plus another constant into x, plus this constant I'll consider it as d, plus one constant into sin x, plus one constant, say f, into cos x. What I'm doing? I'm just taking equations to every function, and also the constant function we can say. Okay, I wrote function of x with the help of a, that is, I took a as its quotient. I wrote x square by taking b as its quotient, and I wrote x using c as its quotient, and I wrote constant using d as its quotient, right? And I wrote sin x using e as its quotient, and I wrote cos x using f as its quotient. So this is the yp. Simply by looking at q of x, I can write, since you're having x cube, you'll get ax cube plus bx square plus cx plus d. Okay, x cube, its derivative is some constant to x square, you will get in the next term, and its derivative is some constant into x. Its derivative is derivative of cx with respect to x is c, right? You'll get some constant. Forget about the unknowns. You'll get one constant. Likewise, sin x. You'll get this sin x, and derivative of sin x is cos x. You'll just write a constant equations, not constant equations. You can call it as undetermined equations. Here a, b, c, d, e, f are undetermined equations. Okay, I hope you'll understand. So this is the way we have to choose yp such that it satisfies the given equation. We have written the given equation in this format so that we can apply yp in this equation. Okay, we'll see that later. So this is how we write yp. Q of x and linearly independent derivatives is written in finite set form. Okay, now we picked a yp. See, our yp has a term of q of x and its linearly independent derivatives, a term of q of x and its derivative. Okay, x cube is a term which we have picked from q of x and these are its derivatives, and sin x is a term of q of x and it is its derivative. Okay, simple, it's just simple. Fine, now we have let yp equal to ax cube plus bx square plus cx plus d. I can write it directly but it's hard to explain, so I'm trying my best to convey the proper way, to convey yp, how to find yp in proper way, I can say. Right, we have picked yp such that it satisfies the given equation. Here you cannot just write substitute yp because it is an operator form d, so I have reduced this to equation in terms of y so that it is easy to apply yp. Okay, we have picked yp such that it satisfies the given equation, so the given equation becomes yp double dash minus 2yp dash plus 3yp equal to x cube plus sin x, which is nothing but yp satisfies the given equation. Okay, fine. Now in this equation you have yp, yp dash and yp double dash, right? We have only yp, so we need to find yp dash and yp double dash. Let's find it out. Yp dash equal to a into derivative of x cube is 3x square plus b into derivative of x square is 2x plus c into derivative of x is 1 plus derivative of constant is 0 plus e into derivative of sin x is cos x plus f into derivative of cos x is minus sin x, which gives us 3ax square plus 2bx plus c plus e cos x minus f sin x, right? Now find yp double dash is equal to 3a into derivative of x square is 2x plus 2b into derivative of x with respect to x is 1 plus derivative of constant is 0 plus e into derivative of cos x is minus sin x minus f into derivative of sin x is cos x, which gives us 3 to the 6ax plus 2b minus e sin x minus f cos x. Now we got yp, yp dash and yp double dash. Let's substitute all these three in this equation. We can write the given equation as, consider the given equation as 1. Okay, 1 can be written as yp double dash minus 2yp dash plus 3yp equal to x cube plus sin x. Why we are writing in terms of yp? Because we have picked yp such that it satisfies the given equation. Okay, fine. Now substitute yp double dash, yp dash and yp in this. You'll get 6ax plus 2b minus e sin x minus f cos x minus 2 times yp double dash, yp dash, which is 3ax, okay, 3ax square plus 2bx plus c plus e cos x minus f sin x plus 3 times yp, ax cube plus bx square plus cx plus d plus e sin x plus f cos x equal to RHS part, that is x cube plus sin x. Now we need to simplify it. See, in order to find yp, I can just go with the direct formula, but by using the direct formula, it is hard to remember because while writing examination, you may forget the formula, okay, and you may feel hard to solve a problem, right? So instead of neglecting the issue, we'll just, instead of facing challenges, you can just find yp with the help of q of x. Okay, now coming to the problem, simplify it. You'll get 6ax plus 2b minus e sin x minus f cos x minus 2 3 is a 6 minus 6ax square minus into plus minus 2 2 is a 4bx minus into minus plus minus into plus minus 2e cos x minus into minus plus 2f sin x plus 3a x cube plus 3bx square plus 3cx plus 3d plus 3e sin x plus 3f cos x equal to RHS part x cube plus sin x. Okay, let me check it once again. I just missed one term, right? So you'll get minus 2c here. Well, minus into minus plus 2f sin x. Fine. Now write the terms involving x cube. You have only one term, right? 3ax cube, or just take x cube common. Okay, and terms that involves x square, only 2, minus 6a plus 3b. Now write the terms involving x. 1, 2, 3 terms. You get, if you take x common from these 3 terms, you'll get 6a minus 4b plus 3c. Now write the constants. 1, 2, 3. b minus 2c plus 3. Now terms involving sin x. Minus e sin x plus 2f sin x, and you have one more, 3e sin x, right? Minus e plus 2f plus 3e plus cos x into terms involving cos x, f cos x minus 2e cos x plus 2f cos x. Just take cos x common from these 3 terms, you'll get cos x times minus f minus 2e plus 3f equal to RHS part. See, we have covered all the terms of LHS, right? Well, now we can write this as 3a x cube plus minus 6a plus 3b into x square plus 6a minus 4b plus 3c into x plus constants 2b minus 2c plus 3d, right, plus minus e plus 3e gives 2e plus 2f into sin x plus minus f plus 3f gives 2f minus 2e into cos x equal to x cube plus sin x, right? We have simplified. Now we'll equate the equations of like terms. Equating the equations of like terms. Okay, I'll begin with x cube. Just equate the equations of x cube. We'll get 3a equal to 1, which gives us a equal to 1 by 3. Now I'll equate the equations of x square minus 6a plus 3b equal to, we don't have any x square term in RHS, so take it as 0. You'll get, substitute a since we have a equal to 1 by 3, which gives us 3b equal to 2, then b equal to 2 by 3, right? Now equate the equations of x. You don't have any x term in RHS, right? So you'll get 6a minus 4b plus 3c equal to 0. Substitute the values of a and b here, since a equal to 1 by 3 and b equal to 2 by 3. You'll get 6 minus 4 2s are 8 by 3 plus 2c equal to 0, which gives us minus 2 by 3 plus 2c equal to 0, right? You can write it as 2c equal to 2 by 3, or c equal to 2 by 3 into 2, where 2 gets cancelled, you'll get 1 by 3, c equal to 1 by 3. See, here you're having 3c, not 2c. I'm so sorry. It's 3, not 2. So you'll get 2 by 3 into 3, which gives us 2 by 9. So the value of c is 2 by 9, right? Now we need to equate constants, quotient of sin x, quotient of cos x. Equate constants. You don't have any constant in RHS part, so take it as 0. You have the value of b and c, where b equal to 2 by 3 and c equal to 2 by 9. Substitute it. Two twos are 4, 4 threes are 12, minus 2 twos are 4 plus 3d, which gives us 8 by 9 plus 3d equal to 0. Three nines are 27. You got the value of d. Now we equate the equations of sin x. You'll get 2e plus 2f equal to 1. Likewise, equate the equations of cos x. You'll get 2f minus 2e equal to 0, or you can write it as minus 2e plus 2f equal to 0. By solving these two equations, you can find the values of e and f. Let's solve these two. Plus 2e minus 2e gets cancelled. 2f plus 2f gives 4f plus 1, which gives us f equal to 1 by 4. Now substitute f equal to 1 by 4 in any of these two equations. I'll put it in this. Okay, I can write it as 2e equal to 2f, right? 2 gets cancelled and you'll get e equal to 1 by 4. So we got the values of unknowns a, b, c, d, e and f, right? Now we can find the actual yp by substituting the values of unknowns in yp, which gives the required yp of the problem. We have yp equal to ax cube plus bx square plus cx plus d plus e sin x plus f cos x, right? Now substitute these values here. We'll get 1 by 3 into x cube plus b, 2 by 3 into x square plus c, 2 by 9 into x plus d minus 8 by 27 plus e 1 by 4 into sin x plus f 1 by 4 into cos x. So you can take 1 by 4 common from these two terms. I mean from the last two terms you'll get yp equal to 1 by 3 into x cube plus 2 by 3 into x square plus 2 by 9 into x minus 8 by 27 plus 1 by 4 into sin x plus cos x, which is required yp. So you can verify yp using the formula yp equal to 1 by f of d into q of x. Okay, fine. We got yp and yc. Let's now find the general solution using y equal to yc plus yq, yc plus yp. Therefore, the general solution is given by y equal to yc plus yp, then y equal to yc e power x times c1 cos x root 2 plus c2 sin x root 2 plus yp 1 by 3 into x cube plus 2 by 3 into x square plus 2 by 9 into x minus 8 by 27 plus 1 by 4 into sin x plus cos x, which completes the problem. Well, we have seen a problem from differential equations using the method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye.